Great, welcome. This is the Greek prefix worksheet. There's a nice little review up top. It talks about how you need those prefixes that represent number of atoms. This page also talks about naming in the stock system, the Roman numeral system, so we're going to need periodic table for those. So what I think we'll do is we'll just name them using the Greek prefix system first, and then we'll go and do the stock system. So carbon dioxide would be 1 carbon, 2 oxygens. Carbon monoxide would be 1 carbon, 1 oxygen. Carbon tetrachloride would be 4 chlorines. Dinitrogen, N2, it's an N. Pentoxide, O5. Tetraphosphorus, that would be phosphorus, tetra is 4. Decoxide, O10. Sulfur, oh, by the way, you're not going to try to simplify that because that is the actual bonding structure. Sulfur dioxide, SO2. So now that we have our formulas, we can figure out the numeral system. It says rename them. So this is going to be carbon and oxide. Does carbon have more than one positive oxidation state? Yes, it does. It has +2 and +4. Those are our two choices. So if we assign this, oxygen's a -2, which means 2 of those would be -4. Carbon would be +4. So carbon, Roman numeral 4, oxide. Carbon monoxide, so if that's a -2, this would be a +2. So now this is carbon, Roman numeral 2, oxide. Carbon tetrachloride, so be carbon something chloride. So this is a -1, which gives you overall -4, so carbon would be +4. Dinitrogen pentoxide, so oxygen's -2, so overall -10. We're going to need a +10, so nitrogen should be a +5. Whoops. So that should be right here. Nitrogen does indeed have a +5. There it is. So, and it keeps flipping on me, sorry. So nitrogen 5 oxide. So we're going to need a +5 for phosphorus. Let me make sure we have that. Phosphorus oxide, it should be 5. So phosphorus +5. Yes, it does indeed have a +5. And that should make sense. It's underneath nitrogen, so in the same group we should have similar oxidation states. Sulfur and oxide. Let's assign oxidation states. So this is a -2. Overall -4, so this should be a +4. IV. So let's just double check that that does indeed exist. Sulfur +4. Yes, it does indeed exist. Okay. So then it says, given the formula, write the name using the Greek prefix system, then rename using the stock system, the Roman numeral. So this is sulfur trioxide. Let's do all the Greeks first. Then we have dinitrogen trioxide. Don't forget the prefixes. 5 through 10 are on the reference tables under table P. This is just 1 phosphorus for phosphorus tribromide. And this is carbon disulfide. All right, so sulfur something oxide, nitrogen something oxide, phosphorus something bromide, and carbon something sulfide. Okay, so oxidation states. I'll use a different color. So this is a -2, which means overall the oxygens is a -6, so sulfur should be a +6. So let's make sure that exists. Going back to the reference table, sulfur +6, yes, it has it. And then oxygen's -2, which overall means -6, which means this must be +3 to give us a +6. Nitrogen has like every oxidation state under the sun, so that's going to exist. Bromine is -1, but there are 3 of them, so -3. So phosphorus should be +3. Carbon is, we don't know. Sulfur is -2. But there are two of them, so -4, so carbon should be a +4. Oh, there's a kitty cat. All right, so Greek naming system, again, sort of an antiquated system, but still might see it somewhere. All right, thanks.